Climate change and reduction of CO2 emission is a very popular topic today, and even more popular in the iron and steel industry, as the iron and steel industry is one of the largest industrial CO2 emitter, together with the cement industry, responsible for about 7% of total global CO2 emission, which is quite a lot. We're here based in Austria. Austria is a small country, but a comparable large steel industry. So for a country like Austria, the steel industry is even more relevant in CO2 emission, responsible for about 12% of the global emissions. Reduction of these emissions is a target which is driven from several sides. In Europe, we already see that this pressure is generating results. So the European Union decided to implement a carbon tax. You can see the typical price of this tax on the graph behind. It's already reached a value of 100 euros per ton last year. So this is giving already a big incentive for the industry to change. So there is big money behind. On the one hand, what companies can save if they reduce. On the other hand, government is collecting a lot of money by this tax, which is giving back as a funding, as support to the industry for this change. This change will change the industry. While we see today very classical plants mainly focusing on one production route, we will see a much wider variety in future. We will see in one plant combination of different production routes right next to each other. We call this new combination a hybrid plant, and this will be the content of the talk today. My name is Gerald Wimmer. I am based here in Linz. I'm responsible at Primetals Technologies for steelmaking. Today mainly BOF converter steelmaking, in future also green steelmaking with smelter and electric arc furnace. And I'm happy that you join us today. To better understand where the emissions in the iron and steel industry are coming from, let's have a closer look on the CO2 emissions of the individual ingredients that we can use to make steel. Most of the steel today is still made via the integrated route, where we have the facility like coking plant, sinter plant, blast furnace, all integrated on one side. And per ton of iron, which is coming from one of these blast furnaces and later transferred to steel, we generate about 1.5 tons of CO2. It's an enormous amount, so more CO2 than iron. Why is this the case? Yeah, the blast furnace is a very energy intensive process, and all this energy we need in the blast furnace is coming from carbon. That's why a lot of carbon is needed to produce 1 ton of iron, generated a lot of CO2 emissions. The good thing on steel is a very sustainable element. We can see on the very right, if we do recycling of steel, and this is luckily already common today. So if we recycle steel and make steel out of scrap, we see that scrap itself has zero CO2 emissions. So by increasing the recycling rate and take maximum scrap rate in our production, we can make steel in a very sustainable way. I think this is a very good message, and we have to be aware of this one, because this clearly underlines why steel itself is a very sustainable material. Unfortunately, even if we do perfect recycling, there is not enough scrap available to feed global demand. So also in future, we will have to make part of our steel out of iron ores. And luckily, there is an alternative process for this one called direct reduction, where gas is used instead of carbon. Today, already existing route is natural gas, which we can see on the second column, reducing the CO2 emissions to about 500 kilograms per ton. In future, if green hydrogen is available in sufficient quantity and at a reasonable price, direct reduction based on hydrogen will be the solution, bringing down the CO2 emissions to value as low as 50 kilograms per ton. So we have quite a wide variety of input materials that can be used to produce steel. And by selection these materials in a hybrid plant, we have a wide flexibility which grades to be made and also which CO2 emissions are related with this production. Direct reduction will play a major role in the steelmaking and will partly replace existing blast furnaces. Today there are two proven solutions for this one. Pellets, which are put to a shaft and reduced there with natural gas or hydrogen. Suppliers of such plants, for example Midrex or Energyron, or using a fluidized bed where finer materials are mixed intensively with the reducing gas. So these processes already exist, and they produce a hot, direct reduced material, so it's not yet molten, and metal and gangue are not yet separated. That's why a direct reduction plant always needs to combine with a furnace which is doing this melting. Today, typically high-grade ores, low in gangue, are used, and these are perfectly fitting to electric arc furnace, where then the melting is done, a reasonably small amount of slag is produced, and the crude steel is then sent to the secondary refining. But these high-grade iron ores are limited. Most of the iron ores available today and used in blast furnace are of lower grade, and these materials do not fit to an electric arc furnace because they would generate much too much slag, making the furnace very slow and very costly in operation. For these lower grade materials, a two-step process combining a smelter and a BOF converter for refining has to be used. So depending on the iron ore availability and the purchasing strategy, plants have to select different route, either go for high-grade material, installing electric arc furnace, or keeping flexibility in the iron ore sourcing, focusing on the larger market of low-grade iron ores, investing in a smelter that might fit an already existing BOF converter. So nicely be integrated in the existing production route. A wide variety of input materials to produce steel exists, as well as different processes. And while today we see big integrated plants focusing on one process and making millions of tons with the same process, we will see in future a wider variety. New processes with lower CO2 emissions will be implemented. You might see, for example, steel plants where BOF converter is operating next to electric arc furnace, feeding to the same cast at the end. We might see plants where still one blast furnace is in operation, but the other hot metal is coming from a smelter which is fed by a direct reduction plant. In this transition phase, we also will see the old processes running in parallel with the new processes until the new processes are fully established, all the certifications are done, and the old processes can be shut down, might last for several years or even decades, this parallel operation. So in such a hybrid plant with a lot of options, we have a lot of opportunities, but you also need a very good planning to use these opportunities and use the unique position and the unique options that you have in your plant to generate a competitive advantage out of this. And this, of course, can be done manually, can be done on paper, but in daily operation, good software solution, good automation will be required to make this planning daily. So a lot of options on the tables, and the question is, what's next? Some plants already made their decision, and for example in Europe we already see first electric arc furnaces and first direct reduction plants under installation. But globally we have to say that now it's the time for strategic planning. There is not one route for green transformation of the iron and steel industry. Each plant has to find its own solution and generate a competitive advantage or maintain its competitive advantage to differentiate from its competitors. In order to do so, the boundary conditions have to be clarified, starting with the legal framework, the energy supply and the energy prices, but also the real step of implementation, how to transform the plant and get a new process into your plant while still running the existing processes. So this will be quite a challenging process where a lot of detailed planning is necessary. One typical question in the steel plant is the logistics, because at the end you have to move a lot of input material and a lot of hot liquid material well in your plant, and such logistics can well be simulated and started with modern simulations tools, which you can see on the video here. So challenging times ahead for the iron and steel industry, challenging times for new processes and plants to be built, but also challenging times for automation and software solution that can master this more complex world that we will see in a hybrid plant. So thanks for joining us. I hope I could give you an insight and some outlook what will happen in the future, and I'm happy to join you in this journey. Bye.